Hi, welcome to this course on real-time workflows with Faceware Studio. In this course, you'll learn to use Faceware Studio to create live and recorded facial performances for metahumans in Unreal Engine. Upon completion of this course, you will have learned how to use Faceware Studio to capture facial performance data using either live video sources or pre-recorded video. You'll learn how to tune and adjust the various facial performance channels being streamed from Faceware Studio, and how to bring those streams into Unreal Engine through either the Live Link plugin or the Glassbox Live Client plugin. Finally, you'll learn how to record those facial performances and edit the resulting animations using tools in Engine. Let's get started. Our facial performance workflow begins here in Faceware Studio. With Faceware Studio, we can bring in a video source, track the face of the performer in that video source, and ultimately stream the resulting tracking data out to Unreal Engine for use with metahumans. Faceware Studio features two distinct input types, live and media, as well as two different tracking models, stationary camera and professional headcam. In this module, we'll explore these different settings, as well as others to configure a video source, begin tracking, and ultimately stream the resulting tracking data out for use by Unreal Engine. Let's begin with the live input type. The live input type allows us to choose a camera connected to the computer running Faceware Studio as a video source for tracking. In this case, I'll use the Select a Camera dropdown to choose a compatible USB connected camera. Once that camera has been selected and activated, the video is available here in the viewport so that we can see the video source as it's streaming live, as well as an indication of the current resolution, the tracking frames per second, the video frames per second, and whether or not it's calibrated. The video source is approximately 30 frames per second, and we're tracking it at real time. However, the resolution is defaulted to a low optimized value of 640 by 480. Faceware Studio tends to default to this optimized setting in order to protect underpowered computers from being bogged down by high-resolution video sources. My video source is a 1920 by 1080 HD camera, so I'm going to choose that from my resolution options here, and also deactivate the Optimize for Real-Time, as this option is still limiting my resolution to the 640 by 360. With Optimize deactivated, now we can see that the resolution is a full 1920 by 1080, and we're tracking at the full frame rate of the camera. Note that if I was interested in throttling the frame rate, I could use the frame rate control. The frame rate control is set at the maximum 60 frames per second. This isn't affecting my frame rate at the moment because the camera is only providing about 30 frames per second. If I wanted to throttle the frame rate down to something lower, I can choose this drop-down control, perhaps choose the option of 10 frames per second. We'll again deactivate Optimize for Real-Time. And now you can see that we're getting our full resolution 1920 by 1080 at a throttled approximately 10 frames per second. I'm going to keep the highest fidelity I can with this live camera, so I'll reset my frame rate to 60 to essentially run with an unconstrained frame rate, and again, deactivate the Optimize for Real-Time so that I get my full resolution. It should be noted that generally, you can see fidelity improvements in tracking, moving from standard definition 640 by 480 up to high definition resolutions such as 1280 by 720 and 1920 by 1080. Resolutions above 1920 by 1080 begin to have diminishing returns in terms of fidelity. So there is not a whole lot of fidelity to be gained by increasing resolution beyond standard HD to things like Ultra HD or 8K. At the moment, we're not calibrated, and therefore we're not generating any tracking data. Our tracking indicators are dormant, and our 3D proxy model isn't moving. In order to initiate tracking, we first need to calibrate a neutral pose from our video source. In this case, I'll need to look at the camera with a relaxed face to calibrate my neutral pose. I'm also wearing glasses at the moment, which really isn't conducive to facial tracking, so I'll take these off, look into the camera with a relaxed face, and use the Calibrate Neutral Pose button in order to calibrate a relaxed starting point. Once I've clicked this button, I've calibrated my neutral pose, and you can see that our proxy model is responding to my motion in the video source, and tracking data is being generated by these indicators. Nice. Now this proxy model is not a metahuman, and so the results that we're seeing here are not necessarily indicative of what we would see with a metahuman model. In later modules, we'll get into how we would evaluate a metahuman performance against the actual data that's being streamed and tune our results accordingly. But for now, it's good that we've got our tracking data working and the results look reasonably good. So all of this has been done with a stationary camera. This camera is sitting still on my desk, and it is a live video source. So let's look at our alternatives. A media source with a head-mounted camera. So I'll choose media here in our input type, and then choose a media source using the Select Media button. There are two options here. A video file, this would be such as an MP4 video or a QuickTime movie, or image sequence, where we have a folder full of individual image files per frame. In this example, I'm just going to choose a video file. In the sample project provided with this class, there is a movies folder in the content directory of the project. And this movies folder contains a video, Hungry Purple Dinosaur. We'll use this video as our sample. Selecting it from our File Open dialog box and clicking Open brings that video source into Faceware Studio. Now this video source was recorded using a head-mounted camera. So the position of our performer's face stays stationary throughout the performance, even though her head is moving, as we can see by motion in the background. However, while this gives us a better view of the performer's face and fills out the frame, the orientation of this video is conducive to tracking, as the face is not vertical in our viewport. We have image rotation as well as image flipping tools here that allow us to adjust the orientation of the video in our viewport for tracking. There are controls here to flip horizontal for the video source, as well as flip vertical. And finally, image rotation. I'm going to rotate this image by 90 degrees to bring our performer's face vertical in the viewport. It is important to note that the flip controls are relative to the video source, not what is currently in the viewport. So with this video rotated 90 degrees, the flip horizontal control might be a little counterintuitive because it will flip the video source horizontally. Remember, the source has been rotated 90 degrees, so this is the left and the bottom of the video is the right. If I choose to flip horizontally, it'll flip along that axis. Restore that. So now that we have our video oriented correctly, we'll also want to make sure we select the appropriate tracking model. This camera is not a stationary camera on a desk or a tripod, but instead it's on a head-mounted camera system. So we'll choose from the tracking model options, Professional Headcam. With Professional Headcam chosen, we can also double check that we're getting the appropriate frame rate and resolution. Let's go ahead and choose the full resolution of this video clip. We'll deactivate Optimize for Real Time and get our native 720 by 1280 resolution for this video. The source file is a 60 frames per second video file, and we are playing that back at full frame rate and tracking at that full frame rate as well. Finally, we'll need to isolate a neutral pose from this performer, calibrate to that neutral pose so that we can begin tracking. I pause and scrub in the timeline here to select a frame that would be suitable as a neutral pose. In this case, towards the end of the clip, we get a good relaxed face, and we'll use that to calibrate our neutral pose. Now that our neutral pose is calibrated, as we play this clip, we're now generating tracking data and seeing it reflected on our 3D proxy model. Finally, now that we have our video source selected, it's oriented correctly, our tracking model is selected, and tracking data is being generated, we're ready to stream this data out so that Unreal Engine could receive it for use with MetaHumans. Currently, our stream indicator is gray, indicating that data is not being streamed out of Faceware Studio. We'll go to the Streaming panel in order to configure that streaming. By default, the data is going to be streamed out of Internet Protocol port number 802. You can use this port control to adjust which port the data will be streamed from if you're already using port 802 on your computer or network with some other software. In this example, we'll leave the port set to 802. For use with MetaHumans, it's important to change our control schema for streaming data to standard. Finally, we have some options here in terms of which facial groups to be streamed, as well as whether we're streaming UVs and our precision in our tracking values. For now, I'll go ahead and set all facial groups to be streamed. UV position streaming is not applicable to MetaHuman performances, and our control value precision of 4 decimal places is perfectly fine for our needs. With all of our streaming values configured, we're ready to stream to the client. Simply activate this control here, and now our indicator is indicating that data is streaming. With our video source now fully configured, being tracked, and data being streamed, we can now move on to our next module, where we'll configure Unreal Engine to use this tracking data on a MetaHuman. In order to have a MetaHuman use the facial performance data being tracked and streamed by Faceware Studio, we'll need to configure a MetaHuman in Unreal Engine to receive that data and apply the data to the facial controls. In this module, we'll go through an example using our example project and apply the data to our MetaHuman from this example project. Once you've opened the example project, it is important to also make sure that you have installed the Glassbox Live Client plugin and activated it for your engine. In my case, I can use the settings button here in the toolbar, choose plugins, and search for the word live. And that should filter me so that I can see the Live Client plugin easily and that it is indeed enabled in my case. With that verified, you'll also want to ensure that you've installed and copied the Motion Logic folder from the download link provided in the Faceware Studio installation instructions for MetaHumans. This Motion Logic folder contains assets and control curves that help translate the data coming from Faceware Studio into the control curve data necessary for operating a MetaHuman face. With those two applied, we can go ahead and begin setting up a MetaHuman blueprint so that it is ready to receive data from Faceware Studio. In this project, under the MetaHumans folder, we have 2 MetaHumans available, Danielle and Nassim. We'll go ahead and use Danielle, so I'll double-click on her folder, and we find that we have a blueprint class set up for Danielle that is the default blueprint class for a MetaHuman that's been installed into this project. In order to configure a version of this that is prepared for receiving data from Faceware Studio, we'll duplicate this existing blueprint. So select the blueprint, Control W to duplicate, and we'll rename the copy in a way that lets us know that it's set up to receive data from Faceware Studio. So I'm just going to use my right arrow to go to the end of this name. I'll delete the 1, and just simply add an underscore FWS for Faceware Studio and hit enter. And now our renamed blueprint copy is set up so that it is BP Danielle underscore FWS, so that we know that this blueprint is set up to receive data from Faceware Studio. Control S to save, and now we're ready to configure this blueprint so that it's ready to receive data. We'll double click to open up the blueprint window. We'll need to add a component here that is the Faceware Live component. So we'll click on the Add button here, type in the word Face to filter our view, and find the Faceware Live component. We'll select that, and that is now added to our MetaHuman blueprint. Selecting this component in our MetaHuman blueprint, we can go over to the details and look for Faceware and configuration and ensure that the IP address is the correct IP address. In this case, 127.0.0.1. This is the universal IP address for the current computer that we're working on. And indeed, Faceware Studio is running on this computer. I can use Control-Tab to go back to my Faceware Studio window and see that it is running, it is tracking and streaming the data. And in the streaming port, we can verify that we're streaming out port 802. Control-Tab back to Unreal Engine, and we see that port 802 is configured. So we're all set for this particular MetaHuman. This can be adjusted for individual actors on a MetaHuman level. So if we wanted to have different copies of Faceware Studio running on different machines driving different MetaHumans, we would simply vary the IP address for each of the MetaHumans in the level at the actor stage so that we could have each of the actors receiving facial performance from a different running copy of Faceware Studio. So with our Faceware Live component configured, now we simply have to set up the facial component so that it is ready to receive that data and apply it to the face of the MetaHuman. So by clicking on the face component and looking over here at details, we see that animation is configured to use the animation mode Use Animation Blueprint. And I'll just expand this a little bit here. And the animation class selected is Face NMBP_C. This is the default for new MetaHumans, but we will be choosing a different blueprint class for the use of our Faceware Studio data. So we'll click this drop down. Again, type in the word face to filter our view. And here we're finding the animation blueprint FW MetaHuman Face. So this is an animation blueprint set up to process the data from Faceware for the MetaHuman face. We'll select that. And finally compile and save all of our changes. And now this MetaHuman blueprint is set up to receive data from Faceware Studio. Let's close this window. We'll click and drag to add Danielle to our level, making sure, of course, that we were using the FWS version of her. I'll tap the F key to fill the frame with her. And using the E key, we'll select the rotation tool and turn her into the light towards the camera. And finally, we'll want to see the MetaHuman data playing out on her face. To do this, we're going to put our editor into simulate mode. So in the toolbar over here, just to the right of the play button, we'll click this drop down and choose simulate. And now we retain all of the functionality of the editor, but we're also running all of our blueprints in simulation mode. So now I can see that Danielle is performing the facial performance that is being tracked by Faceware Studio. We can bring Faceware Studio here, and we can see that. Let's maybe reduce this, and here we are. So there is Faceware Studio tracking our video, and the MetaHuman performing the resulting Faceware track. In this module, we'll learn to set up a MetaHuman actor in an Unreal Engine level so that it can receive facial performance data from Faceware Studio through the Faceware Live Link plugin. For the purposes of this module, I already have Faceware Studio running. Our performer is already calibrated, and streaming is activated so that the data is being streamed out of Faceware Studio. Now we'll move over to Unreal Engine in order to receive that data and apply it to a MetaHuman actor. Here in a brand new level in Unreal Engine, we'll begin by making sure that the Faceware Studio Live Link plugin is installed and enabled. We can do that by going to the Edit menu and choosing Plugins, and then in the search field, typing in the word Face. Here we find Faceware Live Link, and I have it enabled already. If you have the Faceware Live Link plugin installed and it's not enabled, simply check the Enabled box and restart your project, and you'll be ready to go. Now that we know that we have the plugin installed and enabled, we can go ahead and configure Live Link to receive data from Faceware Studio. To do this, we go to the Window menu and choose Live Link. Here we'll use the plus source button to add a source. We'll choose Faceware Live Link and make sure that the IP address of the source matches that of Faceware Studio. In this case, I'm using the universal IP address of this machine since Faceware Studio is running on this machine, and the port number matches the port number configured in Faceware Studio. The subject name is important if you're going to be using more than one Faceware Studio instance on a single network. For example, if you had 2 or more performers, all of them using a copy of Faceware Studio on different machines, you can use subject name to identify each individual source when configuring different metahumans. For the purposes of this demo, I'll just name this Demo FWSLL for Demo Faceware Studio Live Link. Typically, I would use the name of the actor or the character in the subject name. We'll choose OK, and now we see that that source is receiving, and we have a green indicator for our selected source, and it has a subject name of Demo FWSLL. Additionally, if we go back to Faceware Studio, we'll note that the stream indicator has switched from being amber to being green, indicating that it is not only streaming, but that there is also a client connected. Back here in Unreal Engine, our next step is to configure a blueprint for the facial performance capture to stream the appropriate data for the subject name that we set up in our Live Link configuration. Having already followed Faceware's instructions for copying the MotionLogic FWLL folder into our project, we can find that folder here in the content browser. Double-click to open that folder, and we'll find the default BP MetaHuman Faceware Live. This blueprint is configured to receive the data from Faceware Studio and apply it to a MetaHuman face. However, the default configuration doesn't have the subject name that we configured in our Live Link plugin. So let's make a copy of this blueprint by selecting it in the content browser and using Ctrl-W to make a duplicate. In this case, I'll call this duplicate Demo FWSLL. And this matches the subject name that we configured in the Live Link plugin. We can now double-click on this to open it up in the Blueprint Editor. And here we find an Evaluate Live Link Frame node. We'll need to change the subject name from Animation Values, which is the default, and instead choose our Demo FWSLL subject that we had configured in the Live Link window. With this selected, we can choose Compile, and now we see our sample head responding to the data stream. Save, and close. With this blueprint in place, we're ready to set up a MetaHuman that'll use this blueprint for facial performance. We'll go back to the top level of our content browser, enter into MetaHumans, and in this case I'm going to choose my Danielle MetaHuman. Double-click to enter her folder. Again, to preserve the original form of BP Danielle, we'll simply select that blueprint and use Ctrl-W to create a duplicate that we'll customize. This duplicate I'll rename Danielle FWSLL. We'll double-click to open up this blueprint in the Blueprint Editor. Select the face component for this MetaHuman, and we'll change the animation class to be the blueprint that we just duplicated and configured to receive data for this demo. So by clicking this dropdown, I'll enter the word demo into the search. And here I'll find my BP MetaHuman Faceware live link, demo FWSLL. Selecting this now configures this MetaHuman blueprint to receive the streaming data from Faceware Studio. We'll choose Compile, and Save, and Close. Finally, we're ready to use this MetaHuman. We'll drag her from Content into the level, tap F to frame up or fit her into the view. I'll use my rotation here to turn her into the light, and then my mouse navigation tools to be able to get a good view of her face. Finally, to begin receiving the facial performance data, we'll use the Simulate mode here in the Play menu. And that's it. Our MetaHuman is now executing the performance in response to the data streaming in from Faceware Studio. Once we're happy with that, we can use the Stop button to exit Simulate mode. Faceware Studio offers the ability to individually tune every parameter being tracked on a performer's face, adjusting the resulting value before it's streamed to external applications such as Unreal Engine. In this module, we're going to be looking at the Animation Tuning panel in Faceware Studio and how we can adjust these individual parameters through an adjustment value expressed as percentage. In order to review the parameters that we're adjusting, it's good to compare the original performer versus the resulting MetaHuman performance. So let's go back over to Unreal Engine, where we have our MetaHuman already configured to receive data from Faceware Studio. Entering Simulate mode allows us to see the MetaHuman's performance as the data is streamed live from Faceware Studio. We can now return to Faceware Studio and reduce the window size so that we can see the live MetaHuman performance in comparison to the original performer. I'll pause the video playback. Any action that we make here on the timeline will result in a new track of the face, and the resulting data is being streamed to the MetaHuman. Here we can see that the performer's jaw is open a bit more than the MetaHuman performer's. Let's adjust that value. Here in the Animation Tuning panel in Faceware Studio, we have the complete list of every single parameter being tracked on the performer's face. Might be a little daunting to find an individual parameter just by scrolling through, so we'll use the Search for Controls tab here to type in the word jaw. This filters our parameters to only those that contain the word jaw in their name. Here we can see that the jaw open parameter is being triggered, as in that it has a value more than 0. However, the value is a little bit lower than we'd like, resulting in the MetaHuman jaw being closed a bit more than our performer. These parameters act as multipliers. At 100%, whatever value is tracked in the original video is streamed out unadjusted. If we wanted to reduce the effect of this particular parameter, we could reduce the percentage that this tracking value has before it's streamed out to our MetaHuman. So if we wanted our MetaHuman's jaw to stay closed at all times, we could change this 100% value to 0. By doing so, the value being streamed out of Faceware Studio is multiplied by 0, resulting in a constant 0 value. If instead we want to increase the impact of this parameter, in particular in its tracking value, we can enter a value that's greater than 100%. We'll start with trying out 200% here. With 200% entered, we're multiplying the original tracked value, essentially by 2, before it's streamed to our MetaHuman, and now our MetaHuman's jaw is a bit more open than it was before. In this case, 200% looks like it might be a little bit much, so let's bring this back to something like 175. At 175%, we seem to have a better match between how open our performer's teeth are versus our MetaHuman. Another thing that we can note here is that our performer's lip exposes a little more of the lower teeth than our MetaHuman at the moment. So let's look at how open this mouth is. We'll just type in the word open into our search controls, and we only find jaw open. Without knowing exactly which parameter we're looking for, we can instead close out and empty our search for controls, and instead search just a single mouth group. By clicking on mouth, or head, or eyes, our scroll area here in the panel only shows us the parameters relative to this individual facial group. Clicking back on mouth, we can scroll through here and find that there is a parameter relative to how much the mouth has been lowered. Here we are. Mouth lower down on the left and mouth lower down on the right. Let's increase both of these values to see if we can get the lips of this character in our MetaHuman to open a little bit more to reflect the value here in our performer. We'll try 150. And that might be a little bit much. Here you can see this adjustment was only applied to the left side of the mouth. Let's try 125. And then make this symmetrical by applying the same value to the right side. And now we have a little bit of a better match to our original performer. We can take a look at another value by finding another area of the performance. So far, so good. And here we have another discrepancy. Our performer is puckering her lips quite a bit, but our MetaHuman isn't quite there. So let's increase the value for mouth pucker. Here it is in the mouth group, and we'll increase this to 150% to see if that improves. We're getting there. I'll double click once again and set this to 175. That's starting to look better. As we make adjustments to these parameters, we're effectively tuning Faceware Studio when this particular performer is driving this particular MetaHuman. As a result, it would be useful to save these configurations for reuse anytime we want to use this performer with this MetaHuman. Faceware Studio facilitates this through the Profile menu. Here we can save our current profile, which contains all of the settings in our animation tuning. Let's save this profile, and we'll name it based on the first three letters of our performer and the first three letters of our MetaHuman. In this case, CAT for our performer, _DAN for our MetaHuman. And since this is the second time I'm saving this, I'll call this _V02 for version 2. Clicking Save saves that profile, and I can recall that profile by returning to the Profile menu and selecting it from this list. If I want to return to my version 1, I can choose that here. I could also very quickly go back to my default settings by choosing Profile and Default Settings. Now all of our parameters have been restored to 100%. I'll return to my version 2 by choosing Profile and Version 2. Finally, if I no longer have use for the version 1 file, I can click this red X to remove it from our drop-down list. This would remove the selected profile from that list, and we are still using the profile version 2. Finally, if I had use for that version 1 profile again, I could go back to the Profile menu, choose Load Profile, and find that version 1 file to bring into Faceware Studio. I can now easily select between version 1 and version 2 again, anytime that I need these profiles. In this module, we're going to take a look at one of the most powerful features in Faceware Studio, and that's the ability to adjust individual tracked values through the use of custom Python code. This can be incredibly powerful, as it gives us much more control over individual values than simply using the multipliers that are available in the animation tuning panel. Now, of course, an in-depth lesson on all things Python is beyond the scope of this module, but we can take a look at a specific example where a simple Python expression can be used to fine-tune the results of our facial track. So here's a good example right here. In our performer's face, she clearly looks concerned, yet for some reason, our 3D representation of the track is looking a bit angry. When we look over at the animation tuning panel, we can see that the anger is coming from the fact that the brow down left and brow down right values are fully activated. This gives us these down eyebrows. What would be ideal is if we could identify some control being tracked on the face that is related to this concerned expression that could be used to attenuate the degree to which we're lowering our eyebrows. So let's scroll through the animation tuning panel and look at all the controls that we have available to us. We have some eye look direction controls that are being activated, but they're really not related to this expression of concern. Further down, we have some other controls that are being activated, but again, the jaw open and other mouth controls really aren't directly related to this particular look of concern. Finally, at the bottom, we can see that there are some controls here related to the nose, sneer left and sneer right. These are being activated, and they're being activated because of our performer's look of concern. So let's use this value here as a means of attenuating the degree to which the eyebrows are being lowered. We'll do this by creating a custom effect using the Motion Effects panel in Faceware Studio. To begin the process, we'll click the New Effect button and select a primary control that we'll be adjusting. We'll start with brow down left. Next, we'll select an effect. Rather than use one of the preset effects that are provided by Faceware as examples, we're going to go ahead and create a new custom effect. We'll need to give this effect a name. In this case, it'll be Fixed Brow. Next, we get to define some of the parameters that will be used for the Fixed Brow expression. X, Y, and Z values can be either a value or a control. In this case, we'll want the X value to be the control that we're going to be adjusting, brow down left. So we'll select a control and choose brow down left. Likewise, we'll need to be able to bring in the value from that nose sneer track. So our Y type will also be set to control, and we'll choose select control, type in the word nose, and we'll select nose sneer left. The remaining values can stay the same. We'll choose confirm to set this up. And now we're ready to adjust our Python code. To do this, we can click this launch button, which will open the Python code for this expression using whatever the default tool for editing Python code is as set up on your system. Here's the initial code that Faceware set up for our custom effect. It's a calculate function that receives 5 parameters, x, y, z, c, and m. These correspond to the input values here in the Faceware panel, x, y, z, rate, and intensity. At the moment, the function is simply returning x, which is the incoming parameter. In our case, that's the brow down left. We're just passing through the value at the moment. We can see how this Python script can work if we simply change the return value. Let's adjust it to the value of z. Save our changes, and then refresh here in Faceware Studio. We haven't seen an adjustment yet, but that's because our z value is still set to 1. Let's change this to 0. We should see an adjustment in the left eyebrow. And sure enough, we do. We could set a value of 0.5, or return ourselves to a value of 1. Great, so we know our Python code is working. So now let's set it up so that the nose sneer left, Y input, is able to adjust the degree to which the eyebrows are lowered. Going back to our code, we would do this by making sure we can output X. Here we go, return X. And we will multiply this, attenuate it basically, by an expression of 1 minus y. This expression works to attenuate the degree to which the brows are being lowered, because every one of these tracked values falls into a value between 0 and 1. 0 is corresponding to the calibration pose, the relaxed face, and 1 is fully activated. So, As our nose sneer left value increases, it'll fall in a value between 0 and 1. Therefore, as this increases, it'll subtract more and more from this 1, making a value that's lower and lower that we're multiplying by our x value, which of course is the degree to which the brows are being lowered. So this begins the attenuation process, but it would be good to give the user some control so that this attenuation could be tuned based on the performer's expressions. So we'll multiply this by another parameter. In this case, we'll use the z value. And now that allows the user to adjust the degree to which the attenuation will take place. We do have one last little bit of safety to put in here, and that is because multiplying by z could result in a value that's greater than 1, which will ultimately multiply our brow lowering by a negative value, which could result in some unpredictable expressions. So let's clamp this to a value that's no higher than 1, and we'll use a min expression to do that. So min 1, comma, y multiplied by z, and we need to add one more close parenthesis to finish out our expression. So this way, anytime y times z ends up being greater than 1, the minimum expression will make sure that it is clamped back down to the value of 1. In that case, our entire expression here would be a 0, and brows won't be lowered at all. I think our expression's done. So let's save it and refresh. And sure enough, we now have a little bit of reduction in the degree to which this brow is being lowered. We can increase this by tuning this with this z value. Instead of a value of 1, let's try 1.5. That gives us a little bit. Let's try 1.8. Let's go with that. This looks good. Now, we want to use this same expression on the other eyebrow. We'll create a new effect for the other eyebrow, select the primary control. In this case, it's brow down right. And then we'll select effect. Fix brow is now available under our custom effects. And we can match our parameters accordingly. For X type, we'll set it to control, select a control, and it'll be the brow down right. Y type, also a control, select a control, and again we'll use a nose sneer. We'll also match our z value, 1.8. Confirm, and now our brows match. We can play our animation, and now we'll get more expression from our CG character that matches our original performer. As I hope you can see, this feature in Faceware Studio is incredibly powerful for fine-tuning the results of your facial tracks. One of the more powerful features provided in this Faceware Glassbox workflow for our MetaHuman facial performances is the inclusion of the Motion Logic folder from Glassbox. If we go into this folder in our content browser, we'll find that it contains a directory called Curves. Going into the Curves folder, we find a response curve defined for each value being streamed from Faceware. These curves are used by the Facial Animation Blueprint to fine-tune the performance of the MetaHuman. Each one of these curves provides us an opportunity to custom tune the response of our MetaHuman performance with relation to the performances that are being tracked in Faceware Studio. Let's take a look at an example. If we look at our facial performance being tracked here in Faceware and hit pause, you can see that there's a few moments where we notice that the jaw of our performer is open a bit more than that of our MetaHuman. This performance is a little nuanced, and not necessarily something that we would adjust with a multiplier or want to develop a custom Python script for. Instead, we could easily define a response curve using one of the curves in the Motion Logic folder that allow us to tune the response of our MetaHuman face in regards to the performance being tracked in Faceware Studio. So let's go ahead and do that for the jaw. I'll go here into our Unreal Engine set up, I'll stop simulation and find the curve that drives our jaw open. So I'll go here into Search Curves and type in jaw. And here we find that there's a curve that's called Base Jaw Open. Now, rather than edit the existing curve, I'll make a copy of this so that I can make a custom set of responses for just this metahuman. So I'll select the jaw open curve, hit Ctrl W to duplicate it, and simply add a suffix of VO2 to the end of this. So I'll delete the default one, underscore VO2. Hit Enter, and finally right-click and choose Save to save this new version of the curve. Next, I want to make a new version of the facial performance blueprint so that I can preserve the original blueprint for future metahumans that will use the default curves. So I'll go back to our Motion Logic folder, deactivate my search filters, and find the ABP FW MetaHuman Face blueprint. Again, this blueprint is currently configured in the face component of our metahuman to drive that facial performance. Selecting this blueprint, I'll use Ctrl W again to create a duplicate. Again, adding the suffix VO2 to the end. So I'll delete one, underscore VO2. Enter, and right-click, Save. With this blueprint saved, we can now take the face component of our metahuman and set it to use this new blueprint. Clicking on here, we'll choose the version 2 of this blueprint. So now, our metahuman is being driven by our new copy of the blueprint. The next step in our setup is to configure our blueprint so that it uses the new curve that we create to drive the jaw. So we'll double-click our version 2 blueprint to open the blueprint editor. I'll maximize this window, and here on the right side, we can see all of the different curves that are used by this blueprint to drive our facial performances. Let's scroll down to find the jaw curves. Here they are. And here we have the jaw open curve. So we'll select this, and instead of using the default jaw open, we'll use the version 2 version of our curve. With that change made, we want to make sure to hit Apply here in the lower right-hand corner. And finally, use Compile and Save to complete our changes. With this done, we can close our blueprint editor, and now our facial performance will be driven by that new curve. Finally, let's go ahead and open up that curve editor by going into the Curves folder. We'll search for VO2, find our new curve, and double-click. So here's the performance curve. And now let's adjust this by using the data coming from Faceware to inform the adjustments that we make. So I'll make this a little bit smaller in our viewport. Right-click to adjust the position of this curve in the window. And we'll go back to Faceware. And let's see what value we're getting here. Right now, if I go to my Animation tab and look at Jaw Open, I can hover over this and see that a value of 0.21 is being transmitted by Faceware right now. I can click Simulate Mode here in Unreal Engine and see that the jaw isn't quite open enough. In order to have fine control over the position of any keys that I add to this curve, I'm going to deactivate these two magnets that are allowing our keys to be snapped. Horizontally, I'll find a point on the curve that corresponds to about 0.21 and use my middle mouse button to add a new key. I'll right-click on this key and choose Auto. Gives us a little Bezier handles. And now I can click and drag this key vertically to open the mouth of our metahuman a little bit more. Maybe I'll click the first key and adjust its curve handle to make this a little smoother. And now our metahuman jaw, if I look at Faceware, is a closer match to what we have in our performer. Let's see if there are any other values that we might want to address. There's a point here where our performer has her mouth open quite a bit, right here. So again, our performer's mouth is open more than our metahuman's. Let's apply an adjustment to take care of that. Hovering over Jaw Open in Faceware, we see we're getting a value of 0.43. Back in our curve editor, again, horizontally, I'll move along the curve until I find 0.43. Middle mouse click to create a key, right click and set it to auto, and then I'm just going to click and drag that up just a bit more. Excellent. Finally, I'll adjust the end point of my curve so that this eases in to the maximum opening. So in this way, we've now adjusted the response curve of our MetaHuman performance to more closely match the performance that we're getting from our actor as it's being tracked in Faceware. Playing this back, we're getting a much more dynamic performance from the jaw of our MetaHuman and a much better match with our original performance. In our next modules, we'll start looking at how we can record and manipulate the data that we're getting from Faceware.